Okay, now let us discuss class 11 mathematics chapter 2 exercise 2.3. First question, which of the following relations are functions? So you have to identify which of the relations are functions and give reasons. If it is a function, determine the domain and range. So consider the first question. The set of ordered pairs are 2, 1, 5, 1 and 8, 1, 11, 1, 14, 1, 17, 1. So if you observe that no two ordered pairs have the same first element, so all the first elements are different, so in that case it's a function. That is, every element of the set will have only one image. So if you consider a domain and a range, so every element in the domain has got only one image, then it is a function. But it should not have two different images. That means the first element should be different. So here it satisfies the condition that no two distinct ordered pairs have the same first element. So it's a function. So it is a function, and the domain is set of all the first elements 2, 5, 8, 11, 14, 17, and the range is set of all the second element. Here only one second element is there. So this function is called many to one function. So all the many elements in domain is related to only one element in the range or the codomain. So it is called the many to one function. So it's a function. And second question is 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 17. Here also we observe that no two distinct ordered pairs have the same first element. So all the first elements are different, and also of course the image is also different. So it is one to one function. So it is a function. So domain is 2, the set of all first elements, that is 2, 4, 6, 8, 10, 12, 14, and the range is 1, the set of all second elements in the ordered pairs. So 1, 2, 3, 4, 5, 6, 7. So it's a function. And third example, 1, 3, 1, 5 and 2, 5. When you observe the first two ordered pairs, you get 1, 3 and 1, 5. That is, f of 1 is 3, f of 1 is 5. That is, one has two different images. So it is not a function. As per definition of the function, each element will have only a unique image, but this has one element has two different images. It's not possible. And second question, find the domain and range of the following real functions. So f of x is equal to minus mod x or negative mod x. So domain R is set of all real numbers, because x can take, modulus definition is negative mod x, so x can take any real value, still the function is defined. So domain is set of real numbers, and the range is negative or set of all negative real numbers. Or in case if you want to write in interval form, then you can say minus infinity open interval until 0. And 0 has no sign. You can take correct, 0 only. And next question, range is negative set of negative real numbers, that is interval form, you can say minus infinity to 0. And second question, f of x equal to under root 9 minus x square. So when you see any function under root, then to find the domain, the value within the under root will be positive. That is, 9 minus x square should be greater than or equal to 0. It cannot be negative, because root of negative value is not defined. It's not possible. It's not real. That is defined only in another set of numbers called complex numbers, not here. So real numbers, it's not real. Therefore 9 minus x square should be greater than or equal to 0, which implies 9 greater than or equal to x square, that is x square is less than or equal to 9. So this is when x square is less than or equal to a square, then which implies you can say mod x is less than or equal to a. So this is definition. Using that you get x square less than or equal to 9, that is x square less than or equal to 3 square, so which implies mod x less than or equal to 3. In interval we say minus 3 less than or equal to x less than or equal to 3. So that is the domain. So the domain is in interval form, x lying between minus 3 to plus 3, or you can put it in interval form, in closed interval form, that is negative 3 to 3. So that's the domain. And range is, you can find the range minimum values. You can say that say when x is negative 3, that is f of minus 3 is root of 9 minus 9, 0, that is 0 value, and you take f of 0, you get root of 9, that's equal to 3, that's a minimum value, and a 0 in between value, and f of 3 gives again 9 minus 9, 0, that is 0. So all the values of the range corresponding to the values of the domain, that is minus 3 to 3, the values range from 0 to 3. Therefore the range is 0 less than or equal to f of x less than or equal to 3. That's the range. Range means value of f of x. So next, question number 3. A function f is defined by f of x equal to 2x minus 5. Write down the values of f of 0, f of 7 and f of negative 3. So given f of x is 2x minus 5, and f of 0 is, you substitute x equal to 0, 2 times 0 minus 5, that is 0 minus 5, that is negative 5. And f of 7 is 2 times 7 minus 5, that is 14 minus 5 equal to 9. And f of negative 3 is 2 times negative 3 minus 5, that is minus 6 minus 5 minus 11. So it's a simple question. And question number 4. The function T, which maps temperature in degrees Celsius into temperature in degree Fahrenheit, is defined by T of C equal to 9C over 5 plus 32. Find T of 0, T of 28, T of negative 10, and the value of C when T of C equal to 212. So let us see one by one. T of 0, substitute in the definition T of C, C equal to 0. So 9 times 0 over 5 plus 32 gives 0 plus 32, that is 32. And T of 28, 9 times 28 over 5 plus 32, that is 252 over 5 plus 32. So you get 156, 252, 408 over 5. Or you can say the decimal equivalent is 50.4 plus 32, 82.4. Then T of minus 10 is 9 times minus 10 over 5 plus 32. So that gives minus 18 plus 32 gives 14. And that's the third question. Fourth question, you need to find the value of C. Given T of C is 212. So T of C means 9C over 5 or by 5 plus 32 equal to 212. That is 9C divided by 5 is equal to 212 minus 32. That is 9C divided by 5 is equal to 180. Therefore C is equal to 180 times 5 over 9. When you move the 9 over 5 to the right side, it becomes 5 divided by 9, and cancelling the common factors, you get C is equal to 100. And the last question of this exercise, find the range of each of the following functions. So f of x is equal to 2 minus 3x, where the domain is x equal set of real numbers and x is positive real numbers. And so you take x is positive, that is f is greater than x is greater than 0. So when f of 0 gives 2. And next we'll see how the value takes the next value. So you take f of 1, So x is greater than 0 means it starts from 0, 1, 2, 3, etc. 0 not included actually. So f of 1 is 2 minus 3 gives negative 1. So the value keep on decreasing. F of 2 gives minus 4. So value again decreases. So you observe that f of 0 is 2, which is not true. So actually f of x greater than 0 means yeah. So f of x is less than 2, because the maximum value it can take 2 but not equal to 2, because f of 0 is 2. So for any value just greater than 0 it will be less than 2, and that is to confirm that we take one more value, or one f of 2 or f of 1, whatever the values. F of 1 I have taken here. So 2 minus 3 is negative 1. So you observe that 2 next value is minus 1. The value keep decreasing. So therefore the range is f of x is less than 2. When x increases, f of x decreases, and the limit is x is greater than 0. 0 onwards in f of x is from 2 onwards. So 2 and the value less than 2. Therefore we can conclude that range of f is f of x less than 2. And the second question, f of x equal to x square plus 2, and x is set of all real numbers. And so set of all real numbers, but look at the function definition, x square. Even though x takes a negative value, x square is always positive. It can take a minimum value can be 0. So 0 or greater than 0. Therefore f of x, if it is 0, f of x is 2, and if it is greater than 0 it is more than 2. Therefore the range of values is greater than or equal to 2. And third question, f of x equal to x, where x belongs to set of real numbers, and f of x equal to x. Therefore range of f of x is also set of real numbers. X is set of real numbers, therefore f of x is also set of real numbers. So the range is set of real numbers. So that completes the answer for this exercise.